Hello everyone, welcome to this Practical Action Schools online workshop looking at incorporating sustainability into STEM clubs. I'm Angharad Pass, I'm a primary school teacher in Leeds, a science SLE and consultant, and I also work as a trainer for Practical Action. In today's session, if you could keep your mics on mute, if you've got any questions as we go through, pop them into the chat, and today's session is being recorded, so turn off your video if you don't want to be shown. So to start off, what do you already know about Practical Action? Some of you know a fair amount, others are coming to this quite new. In a nutshell, Practical Action is an international development organisation that puts ingenious ideas to work so people in poverty can change their world. The schools team provide free educational resources to support STEM learning using a global context to engage and inspire young people. So why use Practical Action resources for sustainability in STEM clubs? The resources raise awareness of the Sustainable Development Goals, which are sometimes known as the Global Goals. In 2015, the UN called a meeting with leaders from around 30 countries, including the UK, to work out how best to solve some of the world's biggest problems. They identified 17 goals to end poverty in the world by 2030. These are the Sustainable Development Goals. Many governments and charities, such as Practical Action, are working towards them, and many schools are starting to use the Sustainable Development Goals as a framework for their learning. If you want to find out more about them, there's a great guide that's an Oxfam Teacher's Guide on the Sustainable Development Goals. And if you Google Oxfam Teacher's Guide, Sustainable Development Goals, you should be able to find that quite simply. But as well as raising awareness, many of the STEM challenges and other Practical Action resources link to specific goals. The resources are also linked to the national curriculum of England, Wales, Scotland and Northern Ireland. There's a clear and concise curriculum link document that shows where they fit into the curriculum, and you can find it on the website. Now, I know when you're working in STEM clubs that you might be working with a wide range of children's ages, different year groups, and so although there are certain challenges that fit into certain year groups, don't be afraid to use them. They're really adaptable and you can use them in a really broad range of ages. I've seen the majority of these being used from age 5 all the way up to 14 and beyond. But this is a really good starting point. It gives you kind of a feel for where they could sit. Now, we also have the website. Let me show you that now. This is what the website looks at. It's at practicalaction.org/schools. It's really easy to navigate and you can search for the resources that you want for particular sessions and particular activities. So if we scroll down, if you're looking for a specific resource that you know the name of, you can enter the search term here and search directly for that resource. Otherwise, you can search by age, by category. So for example, you could look at the resources for home learning, or you can look at the Sustainable Development Goals, or you can search by subject, and we've got a variety of different subjects. Some of the school subjects, others are more broad, so things like the environment. Now, if you go to the Sustainable Development Goals in categories, we go here, there's a really lovely resource that's a great starting point. If you're trying to introduce sustainability into your STEM club, this could be a really good starting point. It's an activity that links the Sustainable Development Goals and what their aim is. So that's a great starting point. But if we go back, all the other resources are also here. And I'd recommend having a good look around the website to see what you've got available here. We are going to focus on the STEM challenges today, and I'm going to take you through some of them in a brief amount of detail, and then we're going to focus on 2 more of them in a little bit more detail. Practical Action provide a really wide range of resources, but the STEM challenges are the most popular, and they would be perfect to use in STEM clubs. They challenge children to find their own solution to problems faced by communities in the developing world. This is one of the STEM challenges. It's called Beat the Flood, and it's based on a project in Bangladesh. And it's looking at flooding and how to rebuild and flood-proof buildings, thinking about materials involved, so the absorbency and the strength. It'd be a really great activity to do outside, where you've got lots of room, particularly at the moment where we're thinking about social distancing. You've also got Squash Tomato Challenge. This is a great one, really good fun. And the idea is to be able to move some tomatoes down a mountainside without the tomatoes getting squashed. So thinking about how you can develop some kind of pulley system or some way of getting them down the mountainside. And this one's based on a project in Nepal. Regreen the Desert is linked to drought caused by climate change, and it's based on a project in the Sudan thinking about developing an irrigation system. The Wind Power Challenge was the first ever challenge that Practical Action developed, and it's thinking about access to energy and building a wind turbine. Now, the team at Practical Action have very recently revamped this and launched a new version, so it's even further linked to the Sustainable Development Goals. So it'll be a great one to try. Stop the Spread is potentially a little bit too close to home at the moment, but it's looking at infectious diseases and how to build a hand washing device. And there's a second part to the challenge as well, and it's to develop educational materials for children, and the project's based in Kenya, so that's what it's focusing on. There's also a plastics challenge, and it's looking at reusing and recycling plastic. Now, this is based on a Nepalese women's group who do exactly that. The children go out collecting plastics before school, and they give them to the women, and the women develop them into a new item that can then be sold and can raise money and provide money for food. Really nice one, looking at recycling. Now, the one we're going to focus on first today is called Ditch the Dirt, and it's one of my favourites. And it's investigating water quality, and it's linked to Global Goal 6, which is the water and sanitation target. And it's looking at how you can make water safe to drink and filtering water to be able to do that. Now, when scientists and engineers are looking at what is making water unsafe, they are thinking about the contaminants in the water. And there are three main groups. There's physical contaminants, so things like dirt, broken glass, metals, staples. Then there are biological contaminants, things like bacteria and viruses. And there are also chemical contaminants, things that get into the water system like shampoos or cleaning products. Now, this particular challenge focuses on the physical contaminants, and the idea is to be able to try and filter the water to remove as much of the dirt as possible, hence the name Ditch the Dirt Challenge. Now, in Turkana in Kenya, not only is the water dirty, but the children and women who go and collect the water have to travel long distances. In the project, we're going to be looking at a really simple filtration system. And there is a home learning guide to go with this, as there is with all of the STEM challenges, which allow people to focus on what specifically is needed for each challenge. It breaks it down really simply, a really useful guide for teachers if they are setting work for home and setting these STEM challenges as home learning, or for parents as well. So it's got to the challenge, it tells you clearly and concisely what needs to be done. There's equipment, and for the majority of the STEM challenges, it's things that can be found really easily around schools, around the home, and it's not specific resources that need to be used for this. So junk modelling, things like that. It also tells you where to find out more information. So if you are looking at the home learning guide, it gives you places to go on the Practical Action website where you can find out other things, PowerPoint resources and such. So when I was starting to think about using these activities at home and also in STEM clubs, I started thinking about, well, how can you extend these? How can you bring them into the home learning and make them really fun? So you could be really creative. If this is a project that's going to be happening at home with the current circumstances, you could start off by creating the dirty water. So how can you make the dirty water yourself? What can you find in your house and garden to be able to do that? Now, I've created some dirty water from my garden. It looks pretty disgusting. So the children could actually have that as part of their challenge. Then you could include a scavenger hunt. So we're thinking about filtering water, but what items around the house could be used to do that, to create a water filter, and a bit of scavenger hunt that could start this off. You could extend it into thinking about careers. So what roles might be involved in achieving the clean water? What different scientists and engineers are involved in that? Then you've got looking at what's available at home. So things like what filters do you already have? Have you got a water filter in your fridge to filter drinking water? Can you dismantle it and have a look at the components? There's also a lovely activity using banana skins to be able to filter water, which could extend the learning further. And there's a link to the website there. There's also lots of fabulous, more traditional links, cross-curricular links. For example, looking at the geography of the location, so Turkana in Kenya, and lots of other fabulous links that can be made there. Now, when we're thinking about the challenge, there are some rules. By the end of the challenge, you will get 5 minutes, and the idea is to be able to collect at least 100 millilitres of cleaner water. You need to work safely while you're doing the challenge. Very important, hand washing, but also not drinking the water. It may look cleaner, but it definitely won't be safe to drink. So as the challenge goes on, you're going to be thinking about grading your water. So you're going to want to think about whether it's clear, whether it's cloudy, whether it's dirty or very dirty, and you want a starting point, kind of a base level. So you might want to think about the odour of the water, its appearance, and then giving it a score using the water grading. Now you can find the water grading chart on the downloads from Practical Action on the website. Then the children get given a chance to experiment, to investigate, to test out some filter designs, thinking about the different layers, what materials, the order of the layers and the depth of layers. And then there's also a results table that you can download from the website. But if you're wanting children to develop skills of recording, then you might want to give them their freedom to be able to record results in their own way, in their own table. But the table that you can download looks like this. Thinking about the water before, what does water filter 1 do, how does it change it, and then have another go, a different iteration, what does water filter 2 look like, how does the water change. Once you finish doing the investigating and the experimenting, there's going to be a final filter challenge. So the final filter gets made, and then, as I said in the rules, there'd be 5 minutes to be able to filter the water and to try and get 100 millilitres of water filtered. So I've brought some resources today to be able to do that. I've got my dirty water, which I've graded somewhere between a 3 and a 4 on the scale. It looks pretty filthy to me. And I've got some resources that can be found around the house. I've got some cotton wool. I've got some cleaning cloths. I've got a coffee filter here. I've also got the foot of a pair of tights. And I've got some pebbles, which you can probably hear. And the basis of the filter I'm going to create today is going to be using a plastic bottle, a 2-litre bottle. It looks like this. Now this might be something that needs to be done with adult support. And I've just cut the top of the bottle, and then you can invert it. And this is the basis for one particular type of water filter, but there are many ways you can do this. So I'm going to use this, and I'm going to start building up the filter I'm going to use. Now I'm going to start by placing the foot of the tights around. Now, as I said, this is only one particular way of doing it. There are many different ways you can create water filters and many different materials you can use for the layers. I've got the basis there of mine, my starting point. And I'm going to pop in a coffee filter. So hopefully that will filter out some of the contaminants, the finer ones. And I think I'm going to add in a little bit of cotton wool. And then I'm going to place some stones on top, which will hopefully filter out some of the larger contaminants. So once I've put the cotton wool in, I'm going to put some pebbles in top. Here we go. So hopefully these will filter out some of the larger contaminants, so the bigger pieces. And this is just my first version. I will test it out, and then if I was doing the challenge, I'd look at having another go and changing the layers if necessary. This is a good starting point. So this is what it looks like. So I'm going to put the water through my filter and we'll see what changes. You might be able to see it starting to filter through. It's looking significantly cleaner if you compare the two. I'm going to just pop that to one side for now. Let that keep going. In the project in Kenya, there was some real life solutions that were thought about. You can probably hear the water trickling through as I'm talking. Now, one popular solution, and it's used in other locations, is a biosand filter. And it's cleaning a lot of the contaminants out of the water. And it's a layer of biofilm on the top of the sand, and it removes things like protozoa and metals that are in the water. Now, this isn't the solution that was used in Turkana, because as I mentioned earlier, the women and children have to walk really long distances to collect the water. So what the organisations involved in the local community, Practical Action, did was to create a solar powered pump that pumps the water from deep underground. There's a lot of sun in Turkana, and it means that the water pumped from deep underground is really clean, and it can be pumped locally so that the women and children don't have to go collecting the water from long distances, and it means that they are able to go to school if they're the children, so more girls are able to go to school, and the women are able to grow crops and to find work. And in a day, the water pump can draw 30,000 litres of clean water from underground, and it can reduce the health and danger because of the water being drunk, but also the distances that they're having to travel. The second challenge I want to introduce you to today is the Floating Garden Challenge. And if you've got any children who are taking part in the activities during STEM Club Week this week, this is one that will be being released on Thursday, so keep it top secret. Now, the Floating Garden Challenge is based on a project in Bangladesh where climate change has caused the rainy season to become longer. So there are floods, and the floods are taking up more time in the year. And it means that families who grow crops on their land are really struggling to do so because their land is flooded. So the challenge is to imagine you're working for Practical Action and to think about what issues the families in Bangladesh are having. And the idea is then to design and build a model of the structure that people can grow their crops on, so a floating garden, and a structure that will allow them to grow their crops even when the land becomes flooded. The things that you'll need to consider when you're doing this is thinking about whether the model will float. If so, how can it do that? How can you make the top of the model suitable to grow crops on? And the size of the model, because it's going to need to be tested out in something like a sink or a bath or a paddling pool. You could extend the challenge and actually have a go at growing some crops on your floating garden. So things like cress could be grown on there. And you could even try scaling up your garden to make it bigger and try it on a pond. So I've created my version of a floating garden, which I'm going to show you now. Now, this is, again, just one version of it. I've got it here, but there are many ways you can do this. So what I've done as the basis of my garden is I have created a mesh of lolly sticks, and I have attached them to 2 plastic bottles that look like this. So created the mesh there. I've also then created a mesh, or kind of woven in some straws. They're just art straws, paper straws, and then I've got some grass, and I'm laying the grass on top to create a good surface for growing on. So as I say, this is just one version of a floating garden, and there are many ways this floating garden could be done, but that's my example of that. Now, as I say, this is the challenge that's being released on Thursday for STEM Clubs Week, so keep it top secret. In Bangladesh, Practical Action worked with families living in the flooded areas, and they developed an ingenious solution which allowed the families to grow crops on the land. And it is a floating garden. People can grow the crops, they can even keep ducks on their rafts, and it can be used even during the monsoons. The gardens tend to be around 8 metres by 1 metre, and they use resources such as water hyacinths, bamboo and compost, and they can grow a range of different crops. And when the garden starts to decompose, they can be reused as compost. So it's a really sustainable way of being able to farm on flooded land. And the farmers have been trained to make their own floating gardens. So that makes it very sustainable as well, because they are passing on their knowledge. And so more and more families are able to grow crops to feed families and sell at market. Now, when you're working in your STEM club, there are lots of ways that you can celebrate the successes. You can print out certificates from the Practical Action website. Each of the challenges comes with its own certificate. You could use the Practical Action challenges to work towards an Eco School award. You could use the challenges to be able to work towards Crest Awards as well. There are primary awards, the Star and Superstar, and there are also secondary awards as well. The Discovery Award is for primary and secondary, and then you've got bronze, silver and gold awards for secondary. If you need further support, you can contact Practical Action. You can go and contact STEM ambassadors who are really great at supporting things like this. There's also the British Science Association who are involved with CREST, and then there's the Association for Science Education, ASE, who do brilliant conferences and publications. And there's also Engineering UK who are involved in the Big Bang Fair and many other things. Keep in touch with Practical Action. You can go onto the website. You can sign up for the STEM Matters newsletter. You can also contact Practical Action and follow them. They're on Twitter and Instagram and Facebook. And you could also email the schools team at Practical Action, schools@practicalaction.org.uk. To sign up for the newsletter, there's a link here. And if you wanted a pack of STEM posters, you can email Practical Action as well. If you have any questions, please post them into the chat now and I will try and answer them. And I would like to know, as a result of the training today, what are the main things you're going to action in your STEM club within the next 6 months? It'd be really interesting to hear. Thank you for coming to the session today. Have a great STEM clubs week. I hope you manage to use Practical Action resources in your STEM clubs, and it'd be lovely to hear what you get up to. So do share with Practical Action when you've tried some of the STEM challenges. Thanks very much.